Welcome. This is Empowering Introductory Algebra, the series developed to brush up introductory algebra skills leading to college-level math courses. Hi, I'm Bob Young, Assistant Professor of Mathematics at Brevard Community College. With the help of the WBCC staff, we will continue to bring you main ideas of key algebra concepts, tons of examples, great graphics, and study tips to help you become the best mathematics students possible. Let's continue the adventure. Now, in the last episode, we talked about factoring in the form ax squared plus bx plus c, where the first number in front of the x squared was 1, and we're going to continue with that going to the graphic. So this is where we left off last time, and we also noted if a trinomial will factor, the factors of a times c will add to give you the middle number b, and we call those the rainbow numbers. So let's go to one more example with that, and I really tried to pick a nasty one here to start out, a trinomial with all kinds of creatures in it, numbers, variables, different powers, and so forth. Now, first off, this is really not in this form, ax squared plus bx plus c, because we've got cubes in here and over here, and we need to somehow figure out how to get to this form. Now remember that first and foremost rule of graphing. Always, always, always look to take out what? The greatest common factor first. And notice I picked an example here where there are common factors. For example, what comes out number-wise? What is the common number between 3, 6, and 45? Yes, 3 would come out. All right, how many x's does a trinomial have in common? 1 in each one, so we can pull out 1x. And we can also pull out how many y's? Yes, each one has at least 1 in it. So we call this the greatest common factor, and when we take that out, what's left goes in the parentheses. So first and foremost rule of factoring, look to take out things in common first. All right, now remember, once we saw that that's the greatest common factor, if it helps you, you can take it and sneak it right underneath each term. So we can put that 3xy underneath each term there. So when we cancel, we'll have our ducks in a row. So what happens is the 3's cancel out, leaving us with x squared minus 2xy. So again, we're dividing number by number, and when we have like terms here, same variables, the rule is subtract the powers whenever you divide same bases. And then we're going to end up with a minus 15y squared. All right, so taking this greatest common factor out left us with this trinomial. Now we are in the form ax squared plus bx plus c. We can go ahead and multiply these outside numbers. 1 times 15 is 15. And notice I've got the pretty colors on the rainbows here. These rainbows just keep changing color. Don't let that get to you, though. All right, so what factors of 15 are going to give me this 2 I need in the middle? If we listed them all, and I don't know if we need to anymore, but we will, 1 and 15 and 3 and 5, no doubt which pair gives me the 2 I need in the middle. And the signs on the 3 and 5 to get a negative 2 would have to be minus 5 plus 3. So we can say these are our rainbow numbers. And we can hum a few bars if you want. I know the film guys back there go, no, please don't hum a few bars, Young, but I will anyway, just to get them. Somewhere over the rainbow. So you can have fun when you do these. All right, so when we're factoring this trinomial to get the x squared, the first 2 terms to get x squared would have to be xx. And then we can go ahead and put the plus 3 minus 5 in here. That will force those numbers on the top and bottom of the rainbow. So we can put plus 3 and the minus 5, or the minus 5 plus 3. It doesn't matter. Now, you know, I have a problem with this answer, though, because when I FOIL this back, what's missing in this trinomial? Oh, the y is gone, Young. What happened to the y? All right, because remember, first 2 terms, x times x, gives me this. The outside 2 terms, or the last 2 terms here, are going to have to give me a minus 15 what? Y squared. So what I'm going to do is put the y's on the end of the last 2 terms. That last 2 numbers there, the last 2 terms, will force this minus 15y squared. So think about FOILing in reverse. And notice now when we take the outside 2, we'll get what? Minus 5xy. The inside 2 will get plus 3xy. And when I add those together, there it is. That middle term is right there. So again, these numbers on the rainbows. On the rainbows. All right, so that is probably one of the toughest examples when A is 1, is factoring out 1 with the greatest common factor. Now let's go back to the graphics for a minute. Some of you have said, that's real nice when A is 1 there, Young. Now, you watching this graphic real closely? Watch what happens in the next graphic. All right, you ready? Everyone's got this one looked at? What happened? Everything's the same, but folks, I'm sorry to say out there in the audience, A, the number in front of the x squared, is not always going to be 1. Daggone it, just makes life more complicated. But notice the notes do not change. If a trinomial will factor, the factors of A times C, the outside 2, will always add to give you that middle number B. And we're still calling them rainbows. So let's go to some examples where A is not 1 and show you it works the same way. All right, now 7x squared plus 15x plus 2, no longer a 1 in front of the x squared. This will throw a little wrench into the works, but don't panic, it'll still work out for us. Let's multiply the outside 2 numbers here, seeing there's nothing in common to take out. 7 times 2, 14. And we need factors of 14 to get what in the middle? 15. So if we listed all the factors of 14, 1 and 14, 2 times 7, gee, which ones will give us that middle, Young? And you can see them again, can't you? And again, we learned in earlier episodes and earlier lessons, if there's 2 plus signs here, our rainbow numbers will have 2 plus signs as well. So there they are. So we have our rainbow numbers identified. Now, when we go to factor this trinomial, we just can't put x and x in here anymore. Like when there was a 1 there, we always put xx or yy or whatever variable came first. We got to worry about this 7 as well. All right, so let's go ahead. The only way I can get 7x squared out of these first 2 terms is if one is 7x and the other is x. Well, there's other ways, but this is how it's going to factor. 7x times x gives me that first term. Now, I want to try to get these rainbow numbers here, so I'm actually going to make my rainbows. 7 times what number over here is going to give me one of these 2 rainbow numbers? And it doesn't take a lot to see, doesn't it? Like 7 times nothing is going to give me 1, is it? Unless I went fractional, and I don't want to do that. 7 times what gives me a plus 14, and again, you won't miss it with the sign, it would be a plus 2. So my plus 14 will be in the top rainbow, leaving me with, gee, I wonder what in the bottom rainbow here, a plus 1. Now what number's in front of this x? 1. So 1 times what number here, the inside 2, will multiply to give me a plus 1? Well, it would be a plus 1 as well. See, so this works the same way. Even when A is not equal to 1, you can force those numbers on the rainbows. On the rainbows. And notice the rainbows have changed colors again. All right, so let's keep working with that same concept now, because students find these type trinomials the most difficult to factor, and we're going to get you by that in no time here. Let's go to the next example. 6x squared plus 23x plus 7. Factor. All right. Nothing in common can come out, so we'll go ahead and take the outside 2 terms. 6 times 7, 42. We'll start listing factors of 42. We want to force a 23 here. Let's see if we can do it. 1 times 42. 2 times what goes into 42? 2 goes in there since it's even 21 times, and there it is. So if that trinomial will factor, the factors of the outside will always add to give you the middle. And since that's a plus 23, and again, these are both pluses, we have to have pluses on both of these. So we have our rainbow numbers, and you can start to feel that power surging in your veins again. Yeah. Now, the trick here is watch out, because to get this 6x squared here, and I'm going to show you where people can get in trouble even with this seemingly nice method, there's a couple choices here to get 6x squared. Now, we could say 6x and 1x will multiply to give us 6x squared. Or there's another possibility, what? We could put 3x times 2x. So Young, which one is it, or will either one work? Well, I'm sorry to say only one will work. if it works at all. Sometimes, remember, these don't work at all and we get prime. So, but this is not one of those cases. I'll hit you with one of those later. All right, so 6, let's see if we can force those rainbow numbers. So I'm taking this 6 here. 6 times what over here gives me a plus 2? 6 times what over here gives me a plus 21? This is not the pair that's going to factor to give me the rainbow numbers. Rats. All right, so let's try down here. And I'm going to make my rainbows again. 3 times what gives me a 2? 3 times what gives me a plus 21? Pay dirt. 3 times a plus 7 gives me the plus 21 I need on the top rainbow. Therefore, if I get the 21 on the top, gee, I wonder what number is going to be on that bottom rainbow here. Yes, it will be the plus 2. All right, so now all you have to do is say 2 times what number here gives you a 2. 2 times a plus 1. And again, we have a nice factored trinomial answer. A nice factored trinomial answer. And remember I said there's other ways to check this. If you're not sure, I mean, you can FOIL that and it will check. Remember, all these variables are, folks, are numbers in disguise. Let x be some number, any real number you want. And I always pick 0 because 0 is such an easy number to check. So if I go plug in 0 in this trinomial for x's here, I get 6 times 0 squared is what? All that goes to 0. Plus 23 times 0 is 0. Plus 7. So when I plug 0 in for all the x's in this trinomial, it spits me out a 7, doesn't it? Now watch what happens in the factored answer down here. If I go putting 0 in for x down here in these parentheses, 3 times 0 plus 1 is going to give me a 1 in the first parentheses when x is 0. 2 times 0 plus 7 gives me a 7. So notice what we have here. We have 1 times 7 as being factors of what up here when we plug 0 in? 7. Boy, that makes sense, doesn't it? And it will work for any number in the universe, any real number. You could put 1 in for x. You'll get different numbers with factors of that number. You could put 2 in for x up here. You play with your Aunt Sally order of operation problems. You'll get another number. You'll have factors of it down here. So nice ways to check things besides just foiling it back. Foiling's the easiest way, but it works for all numbers that are real. So that's great. All right, next example here. We're going to try to change some signs and see if we can mess with you here. So again, nothing in common. So I'm going to multiply the outside two numbers. 9 times 5 is 45 here. And we want to take factors of 45 that'll give us the 12 we need in the middle. All right, so I'm going to start listing them. 1 goes into everything, so I like 1, but that's not going to get us the 12 we need. 2 doesn't go into 45 because it's not an even number. 3, does 3 go into 45? Yes, because if you add up the digits, 4 and 5 is 9. 3 goes into it because it adds up to 9 there. So 3 goes into it 15 times, and I think we got our numbers that give us the 12 already. So since that's a plus 12, the signs on the 3 and 15 must be minus 3 plus 15. And if you think about it, this last term's number is a negative 5, so in the parentheses you're going to have 1 positive and 1 negative, the last two terms, to give you this negative 5. The rainbow numbers will also carry those same signs. Isn't that neat? But here again, Young has given you one where you have a couple options here. You could say, to get 9y squared, 9y and 1y. Now will that work or not, given that we have identified these rainbow numbers? I'll let you all think about it out there for a second. Can I say 9 times something over here is going to give me one of those? Now what are y'all thinking in your heads out there? It should be, ain't gonna work, Young. So what's the other choice to get 9y squared here? Well, I only can think of one other set of numbers that give me 9, and that would be 3y times 3y. So let's see if that works. And I think y'all will be saying, I see those numbers are forming. So we can say 3 times what number over here gives me one of these. You could take your choice. To get negative 3, 3 times a negative 1, and we get the negative 3 or the negative 3y in the top. Which means we better get what in the bottom on the smiley face here part of FOIL? We better force that plus 15 down here. Now, gee, what number would possibly go there then, Young? 3 times, yeah, plus 5. So again, a very nice thing here. I've tried to take this difficult concept of factoring trinomials and just break it into, can you find the factors of the numbers that give you that middle? And it works every time. It's a very nice method there. All right, so I hope you're starting to get the feel for these, because you know what, on the BCC network, we just don't stop with the easy ones. We go to the hard ones, and people are going, oh no, Young, please, I'm begging you. Yeah, so again, we've got a nasty trinomial with squares and xy's and y squares here. And some students might be thinking out there in the audience, man, Young, you're going to make me take 30 times 30 and get 900 and try to get factors of 900 to give me 87 in the middle? Are you crazy, man? Well, most of you know me on this show. Yes, I am crazy, but not that crazy, because there is a common factor that goes into all three of these. And if you remember that 3 rule and the 9 rule I've been trying to push down your throats, this is the 3 rule. You know why I know 3 goes into 87? 8 plus 7 is 15. 3 goes into 15. 3 goes into that number. So I'm going to go ahead and yank out a 3. And that nasty thing will become much nicer momentarily. So when I take the 3 out, I can go ahead and divide each term by 3 if I want to, and that'll leave me with 10x squared plus 29xy. I had to think about that one for a second, plus 10y squared. Now, some of you said, gee, Young, that doesn't seem a lot better, but boy, it is a lot nicer. Watch what happens. Now, when we multiply the outside numbers, instead of getting 900 we would have had up here, we'll get what? 100. So we just need to find factors of 100 that will add to give me 29. Some of you might see them already out there. I'm just going to put them, thinking some of you might see them. They will come out to be 4 and 25. Will be the factors that multiply to give me the outside that will add to give me the middle. If I put what signs? You know which ones. The plus and the plus. The plus and the plus. We have the rainbow numbers. All right, so again, I have some different things going on here. I can go ahead now to get this 10x squared. I have a few possibilities. Let's see what they are. I could end up with 5x 2x, or I could end up with 10x and 1x. Right now, who out there can see which of the ones is going to work? Now, Young, it's always been the second one up to this point that's always worked. But I always like to throw you curves. Actually, I think this first one is going to give us these numbers on the rainbows, if we know which way to go. 5 times what gives me one of these? Aha. Well, I'm not going to get the 4 out of that, am I? But I can get the plus 25 if I say 5 times a plus 5. That forces the plus 25 up here. Then I know I'll have to get the plus 4 down here on the bottom rainbow. So you can keep humming a few bars. Here's those rainbow numbers. And that's why I draw pretty rainbows on every one. So now 2 times what gives me the plus 4? Well, it would be plus 2. Now, here's where you have to be careful on the old rainbow numbers. People, we've been doing a lot without the x's and y's. Now, this one, when you make sure you FOIL this back and check it up here, you get the first 2, gives you the 10x squared. The outside 2 and the inside 2 are not going to give you this. The last 2 are not going to give you this because we're missing the what on the ends? Yes, we're missing the y's. The y's. So once you put those y's in there, you now have your factored trinomial. And don't forget to bring this greatest common factor down. Sometimes students will take this out and then they'll forget to keep bringing it down as part of the answer. So when I put all this back together, including the 3, I would FOIL this and then multiply the 3 back through, I'll get what's up here. So this case down here would not have worked. 10 times nothing would have given me one of these. Okay, let us continue here. Different signs involved in here. I didn't go all pluses again. I stuck a minus sign here in the middle. Anything in common goes into 12, 17, and 6? I don't think so. I don't think so. So let's go ahead and stay with that method. 12 times 6 is 72. All right, factors of 72 that will give me 17. Now, it really feels good when you start doing enough of these at home and you're practicing and you start going, man, I love this. I'm starting to see. Some of you start seeing the numbers before you don't even have to list them all out. Does anyone, I bet you some of you out there already got factors of 72 that will give me 17. It'll come out to be 8 and 9. And the signs on that would have to be both minuses, because think about it, both minuses are going to end up in the parentheses because you have a plus last term here. So both signs in the parentheses will either have to be both pluses or both minuses whenever this happens, but with this negative middle term, they're going to be both minuses. All right, now I really tried to pick one here that's going to drive you all crazy. But you know me, I'll do that. So on this one, think about all the different factors of 12x squared. All right, it could be 12x and 1x. All right, now if you want to put that in there, you can. I don't know if I'm going to go through all of them because I might run out of paper here. But I'll put a few of them in here. Now, is 12x and 1x going to give me any of these rainbow numbers? 12 times what gives me 8 or a 9? Not that one. All right, now other factors of 12x squared. All right, so that first term is very important in forcing these rainbow numbers. 6x and 2x. Now, if I say 6x here, 6 times what is going to give me an 8 or a 9 here? It wouldn't be 6x or 2x, so I'm running out of choices. 12x and x didn't work. 6x and 2x aren't going to give me these, so I'm down to what else gives me 12? 4x times 3x. Now, if 4x and 3x didn't work, you'd have to put cannot factor. It wouldn't work. But I think we can force those numbers given these. So 4 times what gives me a minus 8? It would be a minus 2. So I've got my minus 8 on the top rainbow. And then I'm going to have I know, well, if the minus 8 is on the top, the minus 9 has to be on the bottom. So boy, it is nice because you never make a sign error using this method as well. 3 times what number gives me the minus 9 would be minus 3. And since this one's got the y square on there, when you FOIL, don't forget to sneak those y's back in there. So we have got the factored answer to that trinomial. So these are the toughest examples when a is not equal to 1 here. All right. Good, good, good. Now, this last example here I'm going to go to. Notice I've got a lightning bolt here. Young, where's the rainbows? I don't know. Young, the rainbows are gone. Beware, I'm going to say the false rainbows. There's the false rainbows here, and got to be real careful with it. So watch what happens here. If I take the outside numbers and multiply them, 8 times 5 is 40. Some of you say, Young, I see factors of 40 that give me that 3. And you'll say, Young, I know it. It's going to be, I'll list them all real quick, 140, 220, 410, 5, 8. And y'all are jumping all over 5, 8. That's all of them, aren't you? And you'll say, if I put a what here, a minus 8 plus 5, I can get that minus 3 in the middle. But there's only one problem with that. There's a plus 5 on the end here. So when that last number has a plus there, the signs must both be the same. They must both be positive in here, or they both must be negative in here for those last two terms to multiply to give you a positive. Y'all see what I'm saying? That foiling in reverse there? And the rainbow numbers will also hold. All right, so notice here, these are opposites, so I'd probably have to have some kind of minus sign here in order for this to happen. So this one, no matter which way you try to force it, I mean, you could probably force an answer here, but when you FOIL it, you will not get that plus 5 back. So this is one that they say cannot factor, or I called it earlier a prime polynomial as well. All right, so sometimes it looks like you can get the rainbow numbers, but you can't. You can't.